Hi guys. So the other day we worked on starting these notes on multiplying monomials. I'm going to review what we already did and then continue on here. Okay, so the first example, we were multiplying the three monomials that you see there, 8a cubed b times negative 5ab times negative 2ab to the fifth. What we said is we're going to focus first on the coefficients, 8 times negative 5 times negative 2 first, and that's going to give you positive 80. And then you look at the bases that are the same. So if you look at base a's, a cubed times a, when you add those exponents, that's going to give you a to the fifth. And you just put it right next to it. And then if you look at the next base, oops, that's not highlighter. And then you look at b times b times b to the fifth. You add the exponents, you have b to the seventh. Okay, so your answer is all one term, 80, a to the fifth, b to the seventh. Same idea with example 2, only this time remember that negative x in the middle is really a coefficient of negative 1. So if I focus in on the coefficients first, I have 4 times negative 1 times 2. That's going to be negative 8. That negative goes in front with the 8. And then I look at the x's, then the y's. So x times x is x squared, and y times y cubed is y to the fourth. Again, we end up with one term for our answer, which we call a monomial. And the last one we did the other day was example 3, which we took negative 5mn, and we distributed it to each of the three terms. This was the distributive property. And this first term, negative m squared, is really negative 1m squared. So I multiply negative 5 times negative 1, I get 5. When I multiply m times m squared, I get m to the third. And then I bring down the n. That's the first term in my answer. Then the second multiplication is going to go negative 5 times negative 3, which is positive 15, and then m times m is m squared, n times n is n squared. And then the last term, negative 5 times 4, is negative 20, and we just carry over the mn. And I had asked you guys at the end of class the other day, do you think these could be combined? And we had quickly said that no, they cannot be combined. They are unlike terms. And we made a little note, right? Meaning that the variables and the exponents on those variables are not exact matches. They're not like the same last name we talked about in class, so therefore they can't be combined. You would leave it as a trinomial, 3 terms. Now example 4 looks pretty intimidating, but the way we're going to do it is we're going to multiply these 3 monomials together to get an answer. We're going to multiply these 3 monomials together to get an answer, and then at the end, we're going to subtract the 2. Okay, so it's actually not that bad. And again, when you multiply the 3 monomials, do like we just did, where you do the coefficients. 1 times negative 1 times negative 4 first. So I'm multiplying 1 times negative 1 times negative 4. And think to yourself, what does that give me? That gives me positive 4. And then I just match up the x's and with the x's and the y's with the y's, etc. So x squared times x cubed. Think to yourself, what does that give me? I'm going to add those exponents, and that's going to give me x to the sixth. And then I'm going to match up the y's. So I have y times another y squared here. Think to yourself, what does that give me? That's going to give me y to the third. And then I'm going to match up the z's. So I have z times z, and that's going to give me z to the second. So that's all one term. That's my first product there for the first 3 binomials. Then I'm going to do the second 3 binomials same way. So why don't you guys pause the video and try to get the answer to that product over there on the right-hand side. Okay, so you should have negative 1, and this is an invisible 1, times 3 times negative 2 should have given you positive 6. And then we're going to match up the x's. I have x squared times x to the third. That's going to give me x to the sixth. And I have y squared times y is y to the third. And z times z is z squared. Now we're going to subtract. Pause the video and see what you think you get when you subtract 4x to the 6th y to the 3rd z squared minus 6x to the 6th y to the 3rd z squared. Okay, and you should have negative 2x to the 6th y to the 3rd z squared. So when you subtract, you're only subtracting these coefficients and you're keeping the last name, the variables, right? So if we talked about like terms, we just subtract or add the coefficients, but all the variables and their exponents stay the same in subtraction. Okay, so now looking at example 5, we're going to look at how these apply to variables with exponents with variables. So if I have a to the m times a to the m, think about what you would do with exponents, and you would add exponents. So we would have a to the 2m. Okay, and then if I have example 6, x to the p times x, think about, again, what you would do with exponents. You would add the exponents. There's an invisible 1 here, so I would have x to the p plus 1 power. And same idea with example 7. I would add all my exponents in multiplication. There's an invisible 1 here, so I would have h to the n plus n is 2n plus k plus 1 power. So sometimes we see these little application problems with exponents that are variables. And we're going to go on to how these are going to apply to geometry. Ignore this r over here. That doesn't mean anything. It was from a website. And we're going to find the area of the shaded region. So if you think back to last year, how we find the area of a shaded region is you find the area of the whole rectangle that you see on the outside here, this whole thing. And then we're going to subtract the area of the inside rectangle. Okay, I'm going to write that out. Area of whole rectangle minus area of inside rectangle. So I'm going to multiply for the area of the whole rectangle. I'm going to multiply the outside dimensions, 9x times 16x plus 5. Make sure you have parentheses around the binomial because we're going to have to distribute, minus the area of the inside rectangle, length times width, 4x times 7x minus 2. Again, you need parentheses around the binomial. And we're just going to distribute and use our rules that we're learning now with polynomials. So when I multiply 9x times 16x, think to yourself, what am I going to get? You can use your calculator. You're going to get 144, and be careful, x times x, x squared. And then 9x times 5 is going to be 45x. In the second part here, this negative is attached to the 4x, so we're going to distribute. Think to yourself, what do I get when I multiply negative 4x times 7x? We get negative 28, and be careful, again, x times x is x squared, and then negative 4x times negative 2 is positive 8x. Watch the signs. So we're going to subtract now 144 x squared minus 28 x squared, combining like terms, is going to give me 116 x squared, and then 45x plus 8x is going to give me 53, positive 53x. And that's a polynomial in standard form, going highest degree to lowest degree, that represents the area of the shaded region. Okay, guys, so we're going to try some of these tonight for homework. Use your notes to help you. Okay, thanks.